Last up, not for this worksheet, unfortunately, but last up for our special types of polar graphs, we're going to look at a lemniscate. And it's really funny. I was watching this video at some point and somebody was talking about a lemniscate, but they had like a really fancy accent and it sounded like lemniscate. And all I could hear was Limp Bizkit. So every time I think of a lemniscate, I think of Limp Bizkit. So I don't know what that's going to do for you, but there we have it. So anyway. This type of graph, you can differentiate it from the others right off the bat because we have r squared and we have an a squared. So when you see the squared stuff, lemniscate, okay? The graph is that of kind of like a propeller. It looks sort of like an infinity symbol, okay? So the equations are going to be r squared equals a squared times sine of 2 theta. And then you have r squared equals a squared times cosine of 2 theta. A cannot equal 0. Again, the graph is going to be kind of this propeller shape, okay? Now, I will tell you, in order to type these polar equations into your calculator, they have to be solved for r. The issue here is we have r squared, okay? So please remember, I'm going to kind of scoot down here, that if we want just r, we're going to have to go plus or minus this junk. And r equals plus or minus this junk. Okay, so do keep that in mind. We're going to have to type in like R1, R2. So like R1 is going to be square root of a squared sine of 2a. R2 is going to be negative square root a squared times sine of 2a or cosine depending. Okay, so don't be totally shocked by that. So we're going to have to do a teeny tiny bit of work on these before we can go to the calculator, but it's not going to be anything terrible. Okay, so graph or question 11, example 11 says graph the polar equation. What do you notice about the graphs? Okay, so we have r squared equals 9 times cosine of 2 theta. So r squared, a, well, we have a is going to equal 3. So then a squared is equal to 9. So we get something that fits the bill here. And then we have cosine, and then we have 2 theta as the argument here. So what we need to do is make sure we have this solved for r. So r is going to equal plus or minus the square root of 9 cosine of 2 theta. And we are going to have to type in plus the square root, or not plus, but the positive square root, and then the minus or the negative square root, okay? So let's go to the calculator again. All right, my old graph is still up, so let's go to y equals. We can get rid of whatever's already in there. And I need to go positive square root, so second x squared, and then we want to type in 9 cosine 2 theta. And then for R2, we need to type in negative. Make sure you do the negative, not minus. Do negative. So this button down here beside enter. So negative square root 9 cosine 2 theta. And it's going to be a little wacky when it graphs it. We're going to have like these little middle pieces missing. Just make sure you know to like connect the whole thing. Okay, and you're going to see it kind of graph two things. The reason it's graphing kind of two things is because we have two pieces of the graph. Like we have two, like we have R1 and R2 is what I'm desperately trying to spit out. Okay. So let's see. It's going to take it a second, but there you have it. So there's our cute little propeller. Now, in reality, this does cross through the pole, okay? We just have some weird issues where we have this plus or minus the square root situation, okay? We're going to have issues with the way the graph is going to look for us, but we can sketch this very nicely. So there you have it. That's a lemniscate or Limp Biscuit, depending on who you ask. Okay, let's go back to our worksheet. Notice we go -3 to +3 on the x-axis. Okay, and then we go a little bit past 1 and -1 on the y-axis. Okay, so 1, 2, 3. 1, 2, 3. And like I said, you do want the full graph. You don't have to leave that middle part empty. It's just some weirdness with the calculator. Okay. Now for the next one, we have part B. We have r squared equals 4 sine of 2 theta. Notice here, a would be 2. So that way a squared is the 4 that we have in our equation. We've got sine, we've got 2 theta, we've got the r squared. We're good to go. All we need to do is solve this for r. So to get r alone, we would take the square root of both sides. So we get plus or minus the square root of 4 sine of 2 theta. There's a theta in there. Okay? So let's see what we get here. This one's going to be a little bit different, but kind of cool. So we go to the calculator and we're going to go to y equals, clear out the old stuff. And for R1, I'm going to type in positive square root of 4 times sine of 2 theta. And then for R2, I'm going to type in negative. And again, make sure you do the negative button, not the minus button. So go negative, which is down here on the bottom row, negative square root 4 sine 2 theta. And there we have it. So we have this cute, adorable little, kind of like a propeller. It is in quadrants 1 and 3, and it goes through the pole. There we go. So we have something that's kind of like that. Okay, so there you have it. That's the Lemniscate. The very last example, praise goodness, I swear I've been making these videos for what feels like 17 hours. Okay, so the last example, we're going to graph two equations kind of by hand. And, it's a little tedious, but we know how that goes. Like the whole point plotting method is kind of what we're going to look at here. Okay, so one more video and then, woo, stick a fork in me. I am done almost.